section 3.5, energy and nutrition. In this section, we're going to continue what I started to talk about in 3.4 in converting kilocalories to joules and making sure that we realize that the kilocalories is really a big C calorie, which is what we think about in food. So here we go. 1 hour of swimming uses 2,100 kilojoules of energy. So learning goal, use the energy values to calculate kilocalories or kilojoules for a food. Carbohydrates are the body's primary source of energy. However, when a carbohydrate reserves are exhausted, fats and then proteins are used for energy. So primary fuel is carbohydrates, fats, then proteins. On food labels, energy is shown as the nutritional calorie with a big C. So we've all looked on the back of our boxes of whatever we're eating, and we see calories. Now we may have just thought, well, that was a capital C because that was the beginning of this. But no, it's a capital C because it means capital C in calories. And the same thing with calories from fat over here. You notice it's a capital C, and it actually means something. It means the capital C, calories. In other countries other than the United States, you'll notice that it's in kilojoules. So we're going to convert here. So we know that one big C calorie is 1 kilocalorie, which is 1,000 little c calories. A big C cal is 4.184 kilojoules, which equals 4,184 joules. You know, this kilo prefix, that's what that means. So if you ever wondered how in the world they figure out how many calories a particular food had, they did it with a bomb calorimeter. Not a bomb, but this thing called a bomb calorimeter. And so we had water in here surrounding this. They had a food sample in here, and they ignited it, and the heat released from burning a food sample in this calorimeter, however much the temperature went up, they were able to then determine the energy value for the food. Now, the energy values for the three food types are given in kilocalories per gram or kilojoules per gram. So I'm sure by now you know that if you compare carbohydrate and protein, that it's 4 kilocalories per gram, whereas if you are fat, if you ate fat, it's 9 kilocalories per gram. So on one hand, you don't want to eat the fat because it's more than twice as many calories per gram, all right? But on the other hand, let's say you're hiking Mount Everest and you want to make it where you don't have to pack a whole bunch of food, you can get a lot more bang for your buck out of the fat. So it just depends on what you need to use it for. So now then, it says we can use the energy values given in Table 3.7 to calculate the energy from a food type when its mass is known. So the way we do it is kilocalories is however many grams it is that they mention times our kilocalorie over gram unit. If it was kilojoules, then the gram times the kilojoules over gram unit. So here's some examples of some different energy composition and energy content for some food. So you can look at it. I'm sure that you already know most of these. So let's see. Let's calculate how many kilocalories all of this ends up being from a cup of whole milk. So a cup of whole milk contains 12 grams of carbohydrate, 9 grams of fat, and 9 grams of protein. How many kilocalories does a cup of whole milk contain? So let's look to see. The first thing is, with our 9 grams of carbohydrate and with our 12 grams of carbohydrate, 9 grams of fat, 9 grams of protein, we need the values back in our chart to do the math. And then we're going to use our dimensional analysis, our unit conversion, to do that, even figuring out how many calories we're going to be using that. So here we go. We know that for a carbohydrate, it is 4 kilocalories per gram. We know for a protein it's 4 kilocalories per gram. And for a fat it is 9 kilocalories per gram. So when we do the math, 12 times 4, I know you go, well, 12 times 4 is 48. How come it said 50? Well, it rounded off to the tens place. So that's why. And we know that 9 times 9, I'm hoping you know that it's 81. Well, we're rounding off to the tens. And 9 times 4, I'm assuming you know, is 36. And so just wanted you to know they're rounding off to the tens place. And so when we add these up, we get a total of 170 calories. This is obvious on losing and gaining weight. That you just got to eat less calories than what you're going to expend. Now, knowing and doing is two different hard things. And I know, but I don't do. I wish I did. But anyway, so we know a person loses weight when food intake is less than the energy output. And a lot of things do influence that. So it's not easy